Today's job is to initiate a phylogeny of Blattodea, roaches and termites. So I'm progressively going through the insect orders. The reason for this is to improve the quality of the phylogeny. My earlier iterations to build an insect tree of life did so overall. I would even do inferences for all insects. That was at that stage the challenge was to get a phylogeny which was high quality, just at the very broad level. Now the methods have since progressed, and at this stage I'm aiming for a high quality phylogeny throughout as much as possible. Now to do this really requires a lot of scrutiny at each component, so for this reason I need to go through each insect order individually. Now I've done the hardest ones are what's called the big four insect orders. These are the hyperdiverse ones: wasps, flies, moths and beetles. After that you get the Hemiptera, the true bugs, which are perhaps not hyperdiverse but still pretty big, but after that is a big drop off in species richness and size of the phylogenies. And now we're at the Blattodea, and they should become progressively easier after this stage. So in practice that means the molecular data will be a lot less extensive, the available phylogenies not so many, and it should be quicker to do. So we'll see now. So I've got the backbone. It's still quite a lot of transcriptome data for this order, and I haven't really compiled. I've only got one or two source trees, so I'm just going to run now a quick integration with the Co1 data and then see where all the big gaps are. And so using the same method as before, so just copying directly some commands. So for instance here I'll be building a taxon table as usual from ITIS and NCBI, but just changing a few names here. So let's get going. So I built a taxon table, taxon hierarchy, which integrates components of both NCBI and ITIS, making advantage of the more precise structure of NCBI and it's more tied to available molecular data, and also a bit of the more species comprehensiveness of ITIS, covered in all Co1 data, and yesterday got pulled out the Blattodea from the omics backbone, which is here. It just has all Blattodea and a single outgroup. And starting off with 3 source trees, which will be woefully inadequate, but we'll just going to run it just to see where the gaps are first. So I'll run the grafting script, although only 3 source trees for this. Graft this onto the omics backbone for Blattodea, and we just need species matrix for Co1, omics backbone for Blattodea, taxon table just created, and a list of the existing source trees. So 9 separate subtree grafts of these source trees, from these 3 source trees, and then totally 80 terminals from those 9. So let's try and integrate the available core 1 data with the backbone which we just extended through grafting from the preliminary set of 3 source trees. And to do this we need the species matrix, the backbone, taxon table, and a relational constraints script. Let's try this. And let's check the output, look for the major gaps.